All right, everyone, welcome back. Our last video here is very closely related to the third one we saw. What we're doing now is we're factoring trinomials. And what I mentioned in the last video is that factoring trinomials is really the opposite of distributing. So let's just refresh our memory on distributing, right? What do? Well, we multiply everybody in the first set of parentheses times everybody in the second. And we'll end up with x squared plus 3x plus 2x plus 6. And I just wanted to just take a look and see what we see here, understanding that we will always add these together. Now, there may be positives and negatives there, but we're always going to combine them to create our final answer, right? So 3x plus 2x is 5x, and that 6 remains. Well, let's just investigate a little bit further. Where did this 6 come from? Well, that 6 came from, let's get the same colors, 2 times 3. So this 6 comes from two numbers that multiply to 6. And then, sorry, I'm messing my highlighter colors up today. 5x. Well, that came from the addition of our like terms in the middle. So what we ended up finding is that when we distribute binomials, we always result, when we distribute linear binomials, we almost always result with a quadratic trinomial. So if we wanted to go in the other direction, which is what you're doing in this section, let's see what that would look like. Well, as long as I'm in this form where I have no lead coefficient, right, we imply a 1 here, then we can follow this rule that we can find a combination of numbers that add to our middle number and multiply to our last number. And the way our answer will look in factored form will be a set of binomials. Our leading terms are going to be x and x. Why is that the case? Well, I'm just going to go back to our original example. We are multiplying x times x. So in order to create this x squared, these first two terms must be x. From there, we have to find those combination of numbers that add to 12 and multiply to 32. Certainly different ways of doing this. I think there are many more numbers that add to 12 than multiply to 32. So I would look at my factors. I think 1 and 32, 2 and 16, 4 and 8. That one will work. 4 plus 8 is 12. So my factored form is going to be x plus 4 times x plus 8. We can always check our work by redistributing, multiplying out again, and checking. Just because I feel like this may be our weak point, I'm going to include one more example here. Again, recognize the structure here. We have a trinomial, a quadratic trinomial, right, second degree. So I know in my factored form, I'm going to have in those kind of leading spots, x's. Well, from here, I'm looking for a pair of numbers again. I'm looking for a pair of numbers that add up to -6 and that multiply to +8. So we have to be a little careful whenever we're dealing with negative signs. We have to think about how that affects multiplication, how that affects addition. Well, if I have a negative sum and a positive product, I know that I should have had negative numbers along the way. So if I'm looking for numbers that add up to -6 and multiply to 8, I'm thinking 1 and 8, 2 and 4, -2 and -4 would work. Like I said, we can always check so this is good. That's where we want to stop. Now I'm just going to check to make sure my work made sense. I'm going to redistribute, right, undo the work I did and see if we can recreate the original problem. X times x is x squared minus 4x minus 2x plus 8. And when we simplify, we get x squared minus 6x plus 8, which is where we started. A good sign that we didn't mess this up. Nice work, everyone.